All right, everybody. Today's lesson is section 6.1 properties of exponents. I want you to study what you see on the screen for a moment and understand what a zero exponent does and what a negative exponent does. So let's focus on a zero exponent. The key is this: anything to the zero power has the value of 1 except for 0 to 0 power. That's undefined. A negative exponent is a reciprocal. Now, what does that mean? Well, you got a couple examples right here that could help you understand what that means. So let's go ahead and put some of this stuff into practice and see how it works out. Okay, so what I'd like everybody to do is try to figure out what the answers are to those two problems. Well, let's go ahead and start with part A. By definition, that is 1. Simple as that. Anything to the 0 power has a value of 1. Next question, part B. What is negative 2 to the negative 4th power? It's not a negative number necessarily. What it is a reciprocal. So what you do is you take this value and the exponent becomes positive. That's important to note that. Now I can figure this out even a little bit more. And when I do so, I've got to take negative 2 to the 4th power. Let's think about that. Negative 2 times itself 4 times. What's that going to be? Look at, do that very carefully. That's 1/16th, isn't it? So don't rely on your calculator to get this work done. Think about what it actually is. All right, next problem. Let's take a look at this. So this says simplify that expression and write your answer using only positive exponents. I'm going to highlight that. That's important. Write your answer using only positive exponents. All right, let's begin this process. So I'm going to rewrite this problem. Let's think about this now. I think I'll keep it as a fraction. So the first time I'm going to think about is this 4. There's no other number to deal with that. How about this? Isn't that the number 1? So I guess that'd be 4 times 1. But isn't 4 times 1 just 4? Right. And then finally, do you remember what the role of a negative exponent does? It moves it. And after it moves, it becomes a positive exponent. So I guess I don't need that fraction anymore. So here is the answer. 4y to the 3rd power. All right, how about everybody tries 1, 2, and 3, and let's see what you come up with for your answer for these expressions with exponents. Okay, number 1. By definition, anything raised to 0 power is 1. There's the answer. Number 2, this is a reciprocal. And then 3 times 3 times 3 is 27, right? So this problem is actually 1/27. Next problem, number 3. Now I think what I would do if I have a fraction, I would keep it as a fraction and deal with each part interchangeably. What is anything raised to the 0 power? It's 1. How about this expression down here? It's a negative exponent, isn't it? That means it'll move. So this will be times 2 to the 2nd power. Now there's no fraction left over, is there? No, there's not. So what I'm going to do is I'm going to get rid of this fraction. And 1 times anything is itself. So I guess I just need to figure out what 2 to the 2nd power is, which is 4. Just have to understand how to work with these. Let's go down here. Let's take this expression. I'm going to rewrite it. All right, let's see, what does this become? Let's start with this term. So this is a negative exponent, isn't it? So it's going to move down here. So this is going to go in the denominator, but once it moves, the exponent becomes positive. Let's keep working on this. How about this? This also has a negative exponent. This will move into the denominator, and the exponent becomes positive. Now, what about this? Isn't that 1? It is. So what we're going to do is I'm going to rewrite that over here as a 1. Now, there's nothing left in the numerator, so there's a 1 there as well. If everything cancels out, there's actually a 1 left behind. 3 squared is 9, x to the 5th, and you don't even need that 1 in there, because when you multiply by 1, it's the identity. Okay, next part. Let's talk about some more properties here, okay? So let's start with the product of powers property. So what does that mean? That means if you're going to multiply powers that have the same base, add their exponents. Here's a real example of this. So if you're multiplying two bases together with the same exponent, add their exponents together if they have the same base. Let's look at this. The quotient of the powers property. When you divide things with the same base, subtract their exponents. Look at this. Here's a real example. And then finally, about the power of a power property. If you have that situation, you actually multiply the exponents together. Here it is. And there's the example. Okay, so let's try to put all of this into practice now. Okay, there's 3 problems right there. And once again, write your answer using only positive exponents. That means no 0 exponents, no negative exponents. Part A, what do you think that is? Okay, well, because we're multiplying, we're going to add the exponents together. So that'd be 3 to the 8th power. Now, if you want to figure out what that is in your calculator, you can go ahead and do so. But that's 3 to the 8th power. Let's go over part B. Since we are dividing the same bases, what you can do is you can subtract the exponents, which would be, let me continue this over here, negative 4 to the negative 5th power over 1, which then means this is a reciprocal And I guess what we should do for these problems is maybe get our calculator out and figure out what these actual values are. So we need to maybe go back and do 3 to the 8th power and then do this other problem, part B. So if you actually have real values, you might as well calculate these as far as you can. So the first one is 3 to the 8th power, 3 raised to the 8th. Okay, 65, 61. And then I'm just going to work out the denominator of this. So it'd be negative 4. Now notice how I put it in parentheses. Raised to the 5th power. Negative 1,024. Okay. Let's go down to part C. What do you do when you have a power raised to another power? You multiply. So this will be z to the negative 12, which is a negative exponent. So that's 1 over z to the 12th power. You need to do a reciprocal on that. Okay, let's go ahead and try these. Once again, write your answer using only positive exponents. All right, so number 5, since I'm multiplying, I will be adding the exponents. That'll be 10 to the negative 2, which is 1 over 10 squared, which is 1 over 100. Number 6, when I add those together, I get x to the 0 power, which is 1. Anything to the 0 power is 1. Number 7, the two negatives cancel. I've got the same basis, so that'd be 5 to the 4th power, which is something maybe we need to calculate. So I subtracted my exponents. It's 625. Okay, let's go on to the next problem. Number 8. Okay, in this case, I'm going to subtract the exponents, which is a reciprocal. Number 9, it's a power to a power, so I will multiply the exponents. That's 36, 6 times 6, right? Number 10, I will also multiply the exponents. W to the 60th power. Okay, next part of our lesson. New property. Power of a product property. Basically the same property we had before. Find the power of each factor, multiply. So it looks like this. It's kind of like a little distributive property with powers. And same thing goes here for the quotient property. It's basically the same thing. So if you have a power on the outside, it can basically be distributed with the items on the inside, the terms on the inside. All right, let's go ahead and move on. Let's try some problems. Once again, no negative exponents. So if I'm going to do this first problem, this exponent of 2 gets applied to both of these. So what it equals would be negative 1.5 to the second power, and then y to the second power. So I need to figure out what negative 1.5 to the second power is. Once again, put it in parentheses if you're going to use your calculator. That's going to be 2.25. So this answer is 2.25 y to the second power. Part B. Same thing goes, everybody. That 3 will be distributed to both. It'll be a to the third over, now watch how I write this, negative 10 in parentheses to the third power. And what I'm going to do next is I'm going to figure out what this is. Well, I know a to the third is this. Negative 10 to the third power, if you think about it, is negative 1,000. It's just 3 zeros. No need to use a calculator for that. All right, parts C and D. Let's see if we can figure these out. So in this case, this 4, this exponent of 4, it gets applied to everything. So this would be 3 to the 4th times d to the 4th over 2 to the 4th. So I guess we got a little bit of work to do here. I need to figure out what 3 to the 4th is and what 2 to the 4th is. 3 to the 4th power is 81. 2 to the 4th power is 16. So that's 81 over 16. Okay, so here's my answer. 81 d to the 4th over 16. go to part D. Once again, this -5 gets distributed with everything. So this will be interesting. This will be, okay, this will be 2 to the -5, x to the -5 over 3 to the -5. Now, keeping in mind, negative exponents, what do? They are reciprocals. So this goes down here, this goes down here, and this one actually goes up there. And what happens is each one of these exponents now becomes positive after they move. So I just need to figure out what these values are. So now I need to know 3 to the 5th and 2 to the 5th. 3 to the 5th and 2 to the 5th power. So 243 over 32. Of course, I have the x to the 5th power. Okay. Let's try some practice here. What do you think about number 11? So this gets applied to both. So this would be 10 to the -3, y to the -3. Now that is a reciprocal. Think of it as over 1. You're going to remove everything. So this will be 10 to the 3rd power, y to the 3rd, with a 1 on top. And 10 to the 3rd is 1,000. All right, there we go. Number 12. Okay, so what I need to do is apply this 5th power to everything. It applies to the -4 and to the n. That negative needs to go with something. So really what I should do, I should maybe rewrite this problem. Okay, everybody, so this will be -4 to the 5th over n to the 5th. Now, knowing that is not a negative exponent, that's a negative number. So put it in parentheses. Okay, that'll be -1024 over n to the 5th. There we go. As long as you don't have any negative exponents, that's what matters. Okay, down here, that 5 will be distributed with everything. So here's the way it's going to look. 1 to the 5th, 2 to the 5th, and see if you can catch on what I get here. K to the 10th because I multiplied exponents. And then I just need to figure out 1 to the 5th is actually 1. 2 to the 5th, check on your calculator, is 32. Okay, finally, number 14. So once again, this -2 is going to be applied to everything, okay? So it goes to the 6. That'll be 6 to the -2. Now it goes to the c to the -2. And then finally, it goes down at 7. Now, knowing that that's a reciprocal means that I can move some of these terms, okay? So the 6 goes down here, c goes down here, 7 actually moves up here. We change negative exponents into positive after they move, and then we figure this out. 7 squared is 49, 6 squared is 36, c squared, positive exponents, we're good to go. That's the lesson.